Alright guys, today we're going to talk about transversal angles, and it does say part 1, and that's because this is the first lesson in a series of 3 lessons where we're going to talk about transversal angles and their properties. Alright, so the first thing we're going to do is we're going to define what a transversal is. So a transversal is a line that intersects two or more lines and forms different angles. Alright, these lines can be parallel or non-parallel, and we're going to go through parallel and non-parallel transversal angles first, and these angles are angles that we cannot use to prove lines are parallel. And we're going to see why in just a minute. Alright, let's underline that in red. We cannot use these two types of angles to prove that lines are parallel. Alright, so we're going to start with looking at vertical angles. So if you remember from our angle pairs lesson, vertical angles are angles that are across from each other and congruent. Alright, so we're going to go through and label these on our diagram here. We're going to start with a non-parallel example. So angles A and D are vertical. Angles B and C are vertical. Angles E and H are vertical. And angles F and G are vertical. Alright, so now we're going to go through and label them the exact same way on our set of parallel line angles. So angle A and angle D are vertical. Angle C and angle B are vertical. Angle E and angle H are vertical. And angle G and angle F are vertical. So if we notice, we have the same angles that are vertical in both the non-parallel and parallel examples, which is why we can't use vertical angles to prove that lines are parallel, because those angles will be congruent even when the lines are not parallel. Alright, now we're going to look at our linear pairs. So linear pairs are supplementary, which means they add up to 180 degrees. So we have a lot of overlap here, so I'm not going to color them in, I'm going to list them. Alright, so we're going to start angle A and angle B are linear pairs. Angle B and angle D are linear pairs. Angle D and angle C are linear pairs. And angle A and angle C are also linear pairs. Alright, so we did our top 4. We're going to do the bottom 4 now. We're going to stick with purple. So angle E and angle F are linear pairs. Angle F and angle H are linear pairs. Angle H and angle G are linear pairs. And angle G and angle E are linear pairs. Alright, so we're going to pay attention to these angle pairs here, and then we're going to write them out as well for our parallel line angles. So angle A and angle B, angle B and angle D, angle D and angle C, and then angle C and angle A. These are all parallel, and that's a D. Let me rewrite that. Alright. Now at the bottom, angle E and angle F are vertical pairs, angle F and angle H, angle H and angle G, and angle G and angle E. So we have the same pairs of angles that are linear pairs, even when our lines are not parallel. So linear pairs we also cannot use to prove that lines are parallel. Alright, so now we're going to go into our parallel transversal angles. And these angles are only formed when parallel lines are intersected. And they can prove lines to be parallel. Alright, so there are 5 different types of angles that we're going to go through. Before we do that, we're just going to define, we're going to see the word interior and exterior a lot, and I just want to make sure we all know what that means. So interior is inside, and they are inside of the parallel lines. Misspelled parallel. Parallel lines. Alright, exterior are outside of the parallel lines. Alright, so I'm going to go through and show this to you with colors. So interior are inside, so it's going to be these angles here on the inside. There's 4 of them in this example. Our exterior are outside, so it's going to be these 2 up here and these 2 down here. Are going to be our exterior angles. Alright, so we're going to start by talking about corresponding angles. So corresponding angles are going to be on the same side of the transversal. One will be interior, and one will be exterior. Alright, and an important thing about corresponding angles is that they are congruent, which means that they are equal or have equal measures. Alright, so we're going to go through and label our corresponding angles. So we're going to start on the same side of the transversal. We're going to start by looking at the left side. So we're going to start with angle A. And the angle that is corresponding to angle A, so angle A is exterior, it has to be an interior angle on that same side, which is going to make it angle E. Alright, so staying on that same side, on the left side, now we're looking at angle C. So angle C is interior, so we need to find the exterior angle on the same side of the transversal, which would be angle G. Alright, now we're moving to the right side of our transversal. We're looking at angle B. Angle B is exterior, so we're looking same side but interior, which would be angle F. And our last pair is angle D and angle H. So now we're going to write those out. So I have angle A is corresponding to angle E. Angle C is corresponding to angle G. I'm going to write equal because they're congruent. And then we have angle B is corresponding to angle F, and angle D is corresponding to angle H. Alright, so now we're going to look at our same side interior angles. And these are easy, it tells you where exactly to look. So same side of the transversal, same side of the transversal, and inside parallel lines. And same side interior angles are supplementary. Right, so I'm going to write that in blue. They are supplementary. Right? So we're only looking at the 4 angles that are inside of our parallel lines, and they are on the same side. So we're going to start looking at angle C, and the same side interior angle to angle C is angle E. Now we're on the right side. I'm going to look at angle D and angle F, our same side interior angles. So we're going to write that out as a rule. So angle C plus angle E equals 180 degrees, and angle D plus angle F also equals 180 degrees. And those are same side interior angles. Alright, next one, we have our same side exterior angles. So same side of the transversal, and then we are outside of parallel lines. And same side exterior angles are also supplementary. Alright, so same side of the transversal, we're going to start again on the left. And now we're exterior, so we're going to start with angle A. And its pair, its same side exterior pair will be angle G. And then we're going to have angle B with angle H. So we're going to write out that rule as well. So angle A plus angle G equals 180 degrees. And then angle B plus angle H equals 180 degrees. Awesome. Alright, those are our same side exterior angles. Next one is our alternate interior angles. Alright, so alternate here means opposite sides of the transversal. And inside are parallel lines. Alright, so opposite means one's going to be on the left and one is going to be on the right. And our alternate interior angles are congruent. Alright, so we're going to start on the left side. So I'm going to start by highlighting, let's see, angle C. So that's on the left. Opposite would be the one on the right, which is angle F. And then we're going to look at angle E on the left side and angle D on the right side. So those are our 2 alternate interior angle pairs. So here we have angle C equals angle F, and angle D equals angle E. Alright, those are our alternate interior, and the last angle pair we're going to talk about is our alternate exterior angles. So, alternate again means we're on opposite sides of the transversal. And now we're outside of the parallel lines. And our alternate exterior angles are also congruent. I'm going to write that there. Alright, so we're going to start again on our left side. Let's look at angle A. So that is on the left. Alternate is going to be on the right, and outside, which is going to be angle H. And then we're going to look at angle B is on the right side, outside of our parallel lines. And then angle G is going to be the alternate exterior angle to angle B. So now let's write out our rule. Angle A equals angle H, and angle B equals angle G. So if we have two lines that are parallel, all of these will be true. Alright, so we're going to do two really quick examples of how we use these different properties, and then we will be done. Alright, so in this first example, we know, let me label this example 1. Alright, so it tells us that line 1 and line 2 are not parallel, which means we're going to have to use our vertical and linear pairs to solve for the rest of the angles. So let's go through and label these. I have A, B, C, D, E, F, G, and H. Let's move that C over just a little bit. Alright, so I want to solve for the measure of all of these angles, and I can do it just with these two that they already gave me. So first thing I want to do is go through and find all of my vertical pairs. So I know that angle A and angle D are vertical, angle C and angle B are vertical, angle E and angle H are vertical, and angle F and angle G are vertical. Alright, so that means I can solve for two angles right off the bat without having to do any math at all. So angle A and angle D are vertical. Vertical angles are congruent, which means that angle D also equals 40 degrees. Easy. Alright, angle G and angle F are vertical, which means that angle F is also 145 degrees. Awesome. We have 4 of our angles. We need to solve for 4 more. Alright, so now we need to look for our linear pairs. So angle A and angle B are a linear pair, which means that they add up to 180 degrees. So angle A plus angle B equals 180. I know that angle A is 40 degrees plus angle B is 180. So now I just have to subtract, which means angle B equals 140. Alright, and angle B and angle C are also vertical, which means angle C is 140 degrees. Alright, one more math calculation and we will be done. So angle E and angle F are linear pairs. So angle E plus angle F equals 180. Angle E plus 145 equals 180 minus 145 minus 145. Angle E equals 35 degrees. And angle H is vertical to angle E, so it is also 35 degrees. So we used those two properties of angles that we know. We took our vertical angles and our linear pairs, and we were able to solve for all of these angle measures. Alright, so that's how you would apply that property. Alright, so now we're going to look at example 2. And example 2 is a little bit different. Here, the problem tells us that line 1 and line 2 are parallel. If the problem itself doesn't explicitly say that they are parallel, you can also look for these arrows. And if they're pointing the same way or they have the same number of arrows, that means that the lines are also parallel. So now we're going to use our transversal angle properties to solve for all of our angles. Alright, so first things first, I'm going to go through and label my vertical angles again. Or actually, let's not look at vertical angles at all. So let's start by labeling A, B, C, D, A, B, C, D, E, F, G, and H. Alright, so I have angle B here. So let's look for all of our congruent. So because these lines are parallel, I'm going to look for corresponding angles. So same side of the transversal, one exterior and one interior. So that means that angle F also equals 55 degrees. Alright, let's look at we have exterior angles. We're looking at angle B, alternate exterior angles. So opposite sides of the transversal. Alright, so we have one on the right side, we're looking for one on the left, and outside of our parallel lines, which means that angle G is also 55 degrees. Alright, now we can look at alternate interior. We have angle F and angle C are alternate interior angles. So angle C is also 55 degrees. Alright, and now we're going to look for our supplementary pairs. So let's start with same side exterior angles. So that's going to be angle B and angle H. So angle B plus angle H is going to be 180. I know that angle B is 55 degrees. Plus angle H equals 180. We're going to subtract 55, which means angle H equals 125 degrees. Awesome. Okay, so now we don't have to do any more math because now we have another set of corresponding angles. Angle H and angle D are corresponding angles, which means angle D is 125 degrees. Alright, and then angle H and angle A are alternate exterior angles, which are also congruent. So angle A is 125. And then angle A and angle E are our last set of corresponding angles. So angle E is also 125. So you were able to solve for all 8 of those angles, only knowing this one. So that's how you can apply some of these properties. Alright, we are done for today, and I will see you guys on Friday.